On number one, you're going to want to look at the parallel lines. We're going to look at this parallel line, that parallel line, that transversal. And when I do that, I see that that's 61. So that angle there is corresponding. So y has to be 61 as well. Okay. Then when I look at this transversal, I get this 60 here and that x there. So those are alternate interior angles. So x has to be 60 as well. Over here, looking at that parallel line, and that transversal, I got that angle there and that angle there, which are same side interior. So they are supplementary. Okay, so 18x equals 180. X is 10. I then know by looking at those two parallel lines, that one and that one, cut by that transversal, 2y and this angle here are same side interior. So 2y plus 90 equals 180. 2y equals 90. Y will be 45. This one, you're going to first look at that parallel line, that transversal, and right away you recognize that that angle there and that angle there are corresponding. So x is equal to 3y plus 6. Can't solve that, two variables. Okay. So now I'm going to look at the other parallel lines, that one and that one, cut by that transversal. Now here, there is no relationship between those two angles directly, but I can move one of them. I can transfer a value here, and it doesn't matter which value you transfer, but if this is x here, I should know that this angle here is also x. Those are corresponding. Okay. Now with these two blue angles over here, they should be supplementary because they're a linear pair, so x has to be 60. So x is 60. Now if x is 60, I come over here and say 60 is equal to 3y plus 6. 54 is equal to 3y. Divide by 3 gives me 18 is equal to y. This one here, again, we've got vertical lines, so I'm going to pay attention to those. That vertical line, parallel lines. Pay attention to parallel lines. That transversal. So that 70 and that angle right there are corresponding. Okay, so x has got to be 70. Now there's a couple other things you can do here. What I would do right away is say, okay, if that's 70, this angle here and that angle there are vertical, so that's got to be 50 there. Now, this angle, that angle, and that angle should all add up to 180. So I got 50 and 70, so that's 120. Plus what will give me 180? So 120 plus 60 gives me 180, so y is going to be 60. Question number 5, parallel line. Look at a transversal. I'm going to choose that one first. And when I do that, I see that that angle and that angle are alternate interior. So we get 3x is equal to 42. Okay. So x then has got to be 14. Still going to look at those parallel lines. Okay, but now I've got to pay attention to a different transversal. So a different transversal would be, so that parallel line, let's look at this transversal. So now we should know that this angle here, 90 degrees, and this angle here, those two angles should be supplementary. So 90 plus, now I got to determine what this blue angle is. Well, the blue angle is a combination of 6y minus 6 and 3x. Okay, that angle and that angle should add up to 180. You know x is 14, so that becomes 42 there. So we got 90 plus 6y minus 6 plus 42 is equal to 180. I'm not going to do any further math here for you. You should be able to, at this point, move everything over to one side and then divide both sides by 6 to get this y by itself. Look at question number 6. Again, we've got some parallel lines. This is similar to one of the questions we saw in the notes. I'm going to focus on that line there, and that transversal. When I do that, I know that that's got to be y. Okay. Now let's go back and see if there's any other transversals we can look at here that might lead us to some useful information. If I look at that parallel line, and maybe that transversal, this angle here and this angle here both have to be alternate interior, so they have to be the same. So that's nice. So this is 55. And those are the only two transversals we could look at there, so that's all the information that we can learn from those parallel lines. So now let's look at a different set of parallel lines. Look at that one. Look at that one. Look at that transversal. I recognize that that 50 there and that angle there have to be the same. So let's put 50 there. Okay, and that's all we gain from that transversal. So I'm going to look at a different transversal. If I look at those parallel lines and that transversal, we get this angle here and that angle there to be alternate interior. So now I got x to equal 55. Okay. Now if x is 55, there's a couple different ways I can find y. I can look at this angle, this triangle here, and now I know. Well, let's not even look at the triangles yet, because we at this point really don't know much about triangles. If I know that that's x is 55 by alternate interior angles, I look at that angle there, that angle there, and that one there, and they should add up to 180. They form that straight line right here. So 50 plus 55 is 105, plus then 75 would equal 180. So y is going to be 75. Okay, find values of x, y, and z. So again, I'm just going to highlight parallel lines. So let's look at these two parallel lines here, cut by that transversal. I recognize that angle and that angle should be supplementary. So I'll take 4z plus x plus 24 should equal 180. Two variables, so it doesn't really lead me anywhere right away, so I'm just going to leave it alone and look at a different transversal. I'm then going to look at this purple transversal, and I see that angle there and that angle there are alternate interior, so x has got to be 56. So that's nice. Okay. Now if I want to find y, I actually have to look at a different transversal. I have to look at this top transversal. Yeah, I can look at the top one, I guess. Okay. If I look at that top transversal, we know because of, let's just erase all this. I actually have to look at that parallel line and that parallel line and that transversal to determine something about y. We know y, that angle there, and this angle here should be supplementary. So I'm going to say y plus x plus 24 equals 180. Okay. And now that we've got these three equations, and I know x is equal to 56, I can plug x in there, and that will allow me to solve for z. So I'll let you do that on your own. I can solve or substitute x in over here and solve for y the same way, and I'll let you do that. Okay. And you know, I kind of paused as I was doing this because there are times when you might choose parallel lines in a transversal that don't really lead you anywhere. Okay. I thought choosing, I think it was this one here, that parallel line, and this top transversal was going to help me in this problem, but the way I've got it drawn up, it doesn't, because I would say that angle there and that angle there are supplementary because they're same side interior, but I don't know that portion right there. Okay, so I can't say that those are going to be, I know they're going to be supplementary, but I can't do any work here because I don't know that angle that I shaded in. Okay, so sometimes it might be trial and error on what you need to find, okay, in terms of certain angles and which parallel lines and which transversals to look at. We'll look at number 8. There's multiple ways to do number 8. Okay, you don't have to start at the same spot I start, but you should eventually get to the same conclusions that I make. I'm going to look at that parallel line, and one of my transversals. Maybe I look at that transversal first. What you should notice then is that angle there and that angle there are same side interior, so x has to be 70. Okay. Now what's nice about that, if x is 70, I can look at this parallel line, that parallel line, and this transversal. And now I know that angle there and that angle there are corresponding. So 5y plus 10 should equal x, but x is 70. So 5y equals 60, y equals 12. Okay. Now what I'm going to do is I'm going to go back to looking at a different set of parallel lines. Okay, back to the first set. That one, and that one, and that one. I should know that that angle there and that angle there are corresponding. So z plus 32 is equal to 5y plus 10. And then what's nice about this is that we've got values for y. Okay, so y was 12, so that's 60 plus 10 is 70. And this is z, 38. We'll get there. Okay, z is going to be 38. Working on this one, again, highlight your parallel lines, redraw a picture, whatever you got to do to make things kind of jump out at you. I'm going to draw those, and we'll draw that transversal. So when I do that, this angle here and that angle there have to be supplementary. So 3x plus 90 equals 180, 3x equals 90, x equals 30. Okay. Now, I can also use some angle addition here. That this angle there, this angle over here, and then this angle here, they should form a linear pair. Or I guess not a linear pair, but they should form a straight angle. Okay. So 8y plus 4 plus 2z plus 90 should equal 180. Okay. Now I don't know what y and z are, so right away it doesn't really help me much, but eventually maybe I know what y is and I can find z, or maybe I'll eventually find z and I can find y. So I need that equation eventually. I'm going to look at those parallel lines again. And now I'm going to cut them with this transversal. And when I do that, hopefully you can recognize that that angle there and that angle there are corresponding. So now I've got 8y plus 4 is equal to 68. Subtract 4 from both sides, you get 8y to be 64. Y then has to be 8. I now know y, and I can plug that up here to get 64 plus 4 plus 2z plus 90 equals 180. And now you can solve that equation for z just by moving all this extra stuff to the other side, and you can find z that way. I'll let you do that. These questions, I believe these are 10 and 11. Again, we did one of these we did both these in class just using different values. We want to try to find values so that L and M are parallel. If I look at this transversal here, I want to find out that this angle here and this angle here are corresponding. So I'll say 30 is equal to x minus y. Not very useful right away, but we'll get there. We'll find something else. So we got to look at a different relationship. So I have to look at a different transversal because that was the only relationship I can find from that transversal. So let's look at that transversal. And you recognize that that angle there, 5y, and that angle there, 2x, are alternate interior. So 5y equals 2x. Okay. And you got some options here on what you want to do to solve this system of equations. I'm going to use substitution. If I want to use substitution, basically I got to find out either what x or y is for one of these. So let's just go ahead and solve this equation for x. So if I take and add y to both sides, I get 30 plus y is equal to x. Okay. Now I'm going to take that amount, and wherever I see x over here, I'm going to replace it with 30 plus y. So we get 5y is equal to 2 times 30 plus y. So 5y is equal to 60 plus 2y when I distribute. Subtract my 2y, I get 3y is equal to 60. Y then is 20. Y is 20. Now, if I want to find x, I can plug that back into any one of these three original equations that I came up with. So let's come back up into this one. And if I say that 30 plus y is x and 30 plus 20 is x, so x has to be 50 in this case. This bottom one, okay, we did one of these in class. That line, parallel, that one is the transversal. So these two angles are on the same side and they're interior, so I'm going to say x squared plus 3x equals 180. Okay, I see that power 2, and that thing, when I see that, I want to think factor. And when I want to think factor, I set things equal to 0. So I move that 180 over. X squared plus 3x minus 180 is equal to 0. Now when I factor, I'm looking for two things that multiply together to give me negative 180 and add up to give me positive 3. Those numbers for us are 15 and 12, I believe. Yeah, 15 and 12. So 15 times 12, and the 12 needs to be negative. Okay, because when I add those together, then I get positive 3. So what I'm going to do is I'm going to go x plus one of those numbers, and then so x plus the 15, and then the x minus 12. Set that equals 0. So I'm going to say x plus 15 then has to be 0, or x minus 12 has to be 0. So that solves x to be negative 15 and x to be 12. Now I just got to check which ones of these work. Okay, if I plug in negative 15 right here, I get negative 45 degrees, and you can't have an angle measurement that's negative 45 degrees. So that is an extraneous root, or extraneous solution. It does not work. If I plug it into x squared, I would get 225 for an angle, and right now we know we can't have angles bigger than 180, so that's not going to work. But if I try 12, plug 12 in, I get 36 here, and I get 144 there. And those are both okay angles. They're legal. That one's positive, and that one's positive, and they're both between 0 and 180. But then when I add those together, I do get the 180 that I knew I should have gotten at the beginning. So x is 12. That's my only option.